Welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, smAshomash.com, and we've got an exciting one today. Coronal mass ejections galore. A coronal hole wind stream arrives, and we'll be talking cosmic rays. First, we're going to look at the sun in 304 angstroms to see all kinds of ejecta happening, filamentary behavior. You can see filaments up here ejecting. You can see filaments down here ejecting. You can see filament motion around here. It's exciting stuff. And we do have a coronal mass ejection. It appears to be in a configuration that will miss the Earth to the east. So it's off sort of in this direction from the Earth, according to the data that I see now. And there is some missing data. We'll get to it in a minute. And I'm going to rock this back and forth for a quick moment here at the beginning of the video, right after I vanish. So look in the upper right. You see a bunch of filamentary behavior there. We covered part of that yesterday. And then also in the lower left, you see a bunch of movement down there. And that is the source of the coronal mass ejection that we see. It's sort of in the Earth-facing vicinity, but it is indeed off to the east. Also in the northeastern portion, right up here, there's a great filamentary eruption, and we'll most likely make another video today more in depth and more close up of that. Check it out. You see that bright spot kicking up there in the upper left. A great view, and it looks like just standard potential field force lines sticking out there. It looks just like what you'd see with iron filings and a magnet. Perfect example of a magnetic field orienting the plasma to it. So we're going to get to a bunch more stuff here. First, let's talk about the radio flux. Before we get to helioviewer movies. And the radio flux is currently at 77 solar flux units. Here's the one-year chart on solon.info. And there is your beginning of cycle 25, solar cycle 25 chart. And you can see coming well off of its solar minimal lows and how proportional radio flux is to the sunspot number. Next, looking at helioviewer movie, the first one we've got here, and we're only seeing part of the ejecta here. Not exactly sure why that is. This happens regularly. And throughout the day, you'll see tons of images all over the internet about a coronal mass ejection coming out in this direction. That would be to the east of the Earth. It does not look like a halo injection. When you see a coronal mass ejection that looks like this, that means it's headed directly towards you. You, the observer here at Earth, and this is a combination of the SDO in the center there and the LASCO C2 part of the SOHO spacecraft, located at Lagrange point 1. Next, we're going to look at Lagrange point 5 because we see some ejecta there. Stereo A's coronagraph, and here it is. Also, you see Mercury swinging into the view there, and you can see some of that coronal mass ejection happening on the Earth-facing side. It's pretty diffuse here. I don't think it's covering the entire thing, as we're a couple hours behind here on this data. But you can see some ejecta. For your new viewers, the Earth would be out in this direction from the location of Stereo A. Again, just to repeat, that would be located at Lagrange point 5, Stereo A's coronagraph. And next we've got some close-up helioviewer movies because we've got a sunspot, so we'll get into it. And here's the only image that we got off of helioviewer. And you do get a view of that coronal mass ejection. It looks entirely about to miss the Earth to the southeast. And this is what happens when you get data loss here, folks. It's sort of a normal thing. We're hoping some of that gets restored throughout the day and that it wasn't caused by a thing like a CCD bakeout. where the charge couple device on the spacecraft shuts itself down to prevent itself from being damaged. That's a pretty good view of the coronal mass ejection there. And watch that to play out for the rest of the day. We reported on it first, most likely. Cheers. And here's a full disk view of the local yellow dwarf in 304 angstroms once again. Great view of that filamentary behavior there up in the northeast, as well as some stuff looking like it's happening in the north solar polar field region. We see a little bit of undulations happening up there. Here's the view in 171 angstroms, and you get a view of that filamentary behavior in the northeast as well, right up in this area. So it's visible in both iron UV emission spectra as well as helium emission spectra. Next, the magnetogram. And sunspot 2783 has remained quite stable here. Still an alpha class sunspot. And like I said yesterday, there is a significant possibility of coronal mass ejection, and there you have it. How I'm able to forecast it? Well, sorry, it's a trade secret. We don't even tell our Patreons about that. But we do tell them more than we tell people on YouTube videos, so perhaps consider becoming a Patreon at patreon.com/smAshomash, the true source of funding for the content. Here's a close-up of the sunspot 2783 here, as well as the fields. Again, looking pretty stable here over the past 24. In fact, it may have even grown a little bit. That was my first impression when I did show prep today. And it took nearly an hour to do so, because lots of stuff going on. Here's the close-up in 171 angstroms. Let me just make sure that the stream is good to go, and we are good to go. Here's back to my favorite wavelength, 171 angstroms, one of the UV emission spectra of ionized iron at very, very high plasma temperatures. And we will most likely make a second video today because there's so much activity going on. Leave us a comment if you've enjoyed our smAshomash.org presents The Sun 1 through 5. You can find all of those at smAshomash.com. If you haven't seen those videos, check it out. They're just solar imagery and essentially nothing else. Here's 304 angstroms. Very clear view of sunspot 2783. Just fantastic. And welcome to another edition of the Smash Lights. Now, today's Smash Lights is going to be somewhat shortened. Let's see. First of all, I would remind you, the viewer, that condensed matter matters. Why? Because some of us believe that stars are made of condensed matter and not plasma. If you want to read all about it, perhaps head to our forum. You can link to all of that at smAshomash.com. There's a link to the forum right there. And we've got all 5 smAshomash.org presents the sun videos right there on the home page. We've also got 2 stores there with our Teespring merch. Go check those out. Support the channel that way if you'd like to pick up some gear. They make great gift ideas. And we've even started selling masks because of some issues that occurred last week. We won't get into it. Also, you can find all of our social media accounts behind this little arrow here. And we've added our Discord channel link to that as well. So check out all of that stuff. Get involved at smAshomash.com, smAshomash.org. We're also on all kinds of social media, just to remind you. Instagram, Locals. Just put up a post about what vitamins I was taking today. And let's just talk about YouTube for a quick moment. We've had a few videos demonetized over on YouTube. So if you enjoy the content, please press like and subscribe. Also visit our links. And since we've had videos demonetized, we've had to take measures. So we've just announced a couple more. If you view our community posts, you'll see that we've put some videos that are now BitChute exclusives, such as Smash Lights, Mask This, Mandate This, Lockdown This, Projected Emperor of the Galaxy Elect, smAshomash.com. So there are exclusives over at BitChute. You should certainly subscribe over there. Thanks to our new subscribers over at BitChute. We're delighted to be approaching the 250 subscribers mark there. We're also on Facebook. Again, visit the links at smashamash.com. We would encourage you to branch out into alt tech, as you may have noticed rampant censorship. We're also on Twitter, so follow us on all those sites. And just a quick reminder, thanks to our viewers over at twitch.tv/smashamash, we are creating another live stream right now as I speak. So again, thanks to our Twitch followers as well. Twitch.tv/smashamash, probably the ultimate streaming platform, which is why we use it so much. And here ends today's Smashlight. Look for another video coming out a little later today. Probably 2 more videos, because there's a lot of stuff to talk about. We're going to go into cosmology for a quick moment here as well. Let's talk cosmology. Now, we've been throwing dice, a 1,031-sided die, to figure out what to talk about when it comes to cosmology. Because, hey, when the sun gets boring and it's not doing anything at solar minimum, it's a good time to study other stars, right? So, we've been rolling dice and looking at the Neil Gorell Swift-Bat X-ray Observatory. We're not going to do that today at all. Today we're going to look at cosmic rays. I'm just going to show you the charts here and not comment. We see a little uptick here at the Apatity Neutron Monitor over the past week. We see a little uptick over the Apatity Neutron Monitor, but not the Barentsburg Neutron Monitor. So those are pretty close to each other on the planet, showing vastly different graphs over the past week. Next, we'll look at Athens, Greece. You know where donuts are made, right? In Greece. All right. There's the 30-day chart at Athens. Quite flat over the past 30 days and no big uptick over the past week. Next, Mexico City. Mexico City, flat over the past 30 days as well. And lastly, we'll look at Oulu, Finland, as well as DOMC Antarctica. There's Oulu, flat over the past 30 days, and there's DOMC, flat as well. Monitor these yourself. Don't take my word for it. We encourage our viewers to do their own research, because it's possible for anybody to be wrong, no matter how much they're paid per month to make YouTube videos, and no matter how many book deals they have, and no matter what their reputation is, and no matter how crazy their followers are. People are still regularly wrong, and that is why you should be not ossified in your beliefs, and you should be adapting to new information. So today's featured object is, instead of rolling dice, it's Cygnus X3, which has in the past week come out of its quiescent state. There you have it. There's the past 2 weeks approximately of Cygnus X3's X-ray outputs, as reported by the Neil Gorell Swift-Bat X-ray Observatory. And you can see right here at 0.05, it is out of its quiescent state. It is now in its X-ray loud state, and we've been pleading with radio astronomers to view this object as it does this. I don't know if anybody has. Let's hope a paper comes out. And here's an image of what's going on at Cygnus X3. By the way, it's quite an interesting system, to say the least, in that it is a high-mass X-ray binary. So let's look at it on the 2-mass. There's the 2-mass image. And what's going on here is you've got a massive Wolf-Rayet star, which is approximately the size of Mars's orbit, being orbited in only a period of 4.83 hours, or 4.7, let's say 4.8 hours, by this massive object known as Cygnus X3, the Wolf-Rayet star's little friend. One of the poloidal jets from this is pointed directly at you, the observer, and this is believed to be one of the only known point sources for cosmic ray flux. If you want to read more about it, head to smashamash.com/forum. We've got an entire forum thread all about Cygnus X3. Why? Because cosmic ray flux is very, very important to not only the climate, but also to evolution, perhaps, as it is known that ionizing radiation, cosmic rays, can cause spontaneous evolution to occur. So if you head to the Cosmology forum, just click on that right there at smashamash.com/forum. Click on Cygnus X3 Massive X-ray Binary Celestial Pole Star Deneb. and you can read all about it. Here's a clip. I searched for answers. This is by Andrew Collins, by the way. I searched for answers and was intrigued to find that in the early 1980s, particle physicists using two newly operational proton decay detectors, Sudan, located a half-mile down an old mine in Minnesota, and Nuzex, found off a road tunnel deep beneath France's Mont Blanc, detected the presence of highly unusual cosmic rays. What was so unusual about them? Well, they were detectable under 1,000 feet of granite in Minnesota at a 4.8-hour periodicity. Without further explanation of that, again, I would invite all of our viewers to head to smashamash.com/forum. A lot of interesting stuff there. And our cosmology segments are brought to you in part by our patrons. Please consider becoming a patron. Patreon.com/smashamash enhances the probability that these videos will continue to exist, be publicly visible, and be free to view on platforms such as YouTube, as YouTube pays us just about nothing for the content. Thanks to our patrons, again, the real source of funding for the content, we make about 2 cents an hour via Google fraudware, junkware, AdSense payouts. Thanks again to our patrons. Look for more content coming your way soon at patreon.com/smashamash. And here ends today's cosmology segment. Another regular short section included here at the Smash News Network. Let's get back to daily space weather data. The real-time solar wind. Looks like we're seeing a weak coronal hole wind stream striking right now. We saw the solar wind density a little bit elevated yesterday, reaching a maximum of around 11 protons per cubic centimeter, now dropping down as the solar wind speed comes up, a sure signature of a coronal hole wind stream. There you have that. I don't expect this to get much higher today. It looks like it could have already leveled off. Let's look at the current data. Current solar wind speed around 320 kilometers a second. Current solar wind density down to 4.28 protons per cubic centimeter. KP index is at 0. That's part of the reason why we showed you cosmic rays. And next, looking at the pressure, the magnetohydrodynamic pressure of Geospace. Yes, it's 4 hours of data, courtesy University of Michigan Geospace Model V1.5, which is based on the Space Weather Modeling Framework. And if you're wondering, yes, I did go to the Ben Shapiro School of Fast Talking. I'm not as fast as the guy in the Micro Machines commercials. Anyway, we see the majority of the pressure here in the magnetotail region. It could change as the velocity has increased. Next, looking at ground geospace magnetic perturbations, coming back a little bit closer to home here during this geomagnetic excursion. And there's 4 hours of data on what's going on ground-based magnetometers. Keep in mind this is all associated with the Space Weather Modeling Framework. It's a lot of data tied together. And it does include all sorts of things such as the electron flux measured at the F2 layer. And we've got some comments here. Thanks for leaving comments, Bestoic. Bestoic says, Trump to seize Facebook, Google, YouTube, and all who interfere with election. I'm not so sure that's going to be a thing, or that that's even possible. All news, Fox, CNBC, CNN, etc., to be seized for tampering with election from an executive order signed back in 2018 stating emergency in state for elections. Not sure about that one. And if you viewers out there would like to fact check that, feel free. Thanks for leaving the comment regardless. Be stoic. Cheers. Let's get back to some more data. We don't see any significant proton strikes. There is the 3-day graph of the proton flux. No solar flares. And again, don't get the protons and photons confused. Solar flares are photons, and coronal mass ejections are mostly protons. Next, looking at a star chart. As I'm usually interested in what's going on above my head, I like to use in-the-sky.org and orient mine to the south, as it is where the ecliptic is located from my part of the planet. If you're up before dawn, you may see the third brightest object in the sky, Venus. And you may not see me vanish. Once again, where will you be when Deneb rises? Next, looking at the planets today to show you where stuff is. in the solar system. And by the way, we greatly enjoy doing these videos live. There's where stuff is now. There's where things will be in a week as Mercury swings out of the view of the stereo A coronagraph. Here is, Mercury. Here's the GOES magnetometer, and we're continuing to see little spikes here. As I forecasted, it might be smoother now. Let's see what the situation is on the Gong 2, which is a whole lot of interpolated magnetometer data. Here's the Gong 2 data. It's the top view ecliptic plane field plot, as if you're looking down at the sun from the North Pole at the potential field surface source lines. North Pole ones are noted here in green. South Pole are noted in red. Earth still solidly in the North Pole current sheet. No changes on that expected to come anytime soon. And let's bring up the last image and see if any of these structures have collapsed. There's actually still a chance for more coronal mass ejecta to come out. And there may be a sunspot hiding back in this area somewhere. So that's something to keep an eye on. And when I say eye on, well, the pun is intentional. Here's the line of sight coronal hole plot, which shows you the North Pole oriented coronal holes in green, South Pole oriented coronal holes in red. And that's a pretty big one there associated with the North Pole just rotating to the Earth facing zone. Next we'll show you the line of sight field plot, which also shows you the Z fields coming out of the poles there, the solar Z fields in green and red. Here is the, oh, by the way, for you new viewers out there, this data is based on 51 ground-based magnetometers as well as magnetometers on stereo A and stereo B. It's all part of the National Sunspot Observatory. If you want to look that up yourself, we encourage you to do so. Next, looking at the potential field surface source lines for just the corona. And let's move on to some more data here. Coming back home a little bit to the Earth to look at electron fluxes, which is, by the way, part of that space weather modeling framework we showed you in the Geospace magnetosphere movies. We don't see any charging hazards. We see quite low levels of electron flux. Here's the one-year chart. Forecast is for a dip and then an increase, and I would concur with this. That is exactly what I would forecast. Well done, NOAA. Here is the 3-day chart of the electron flux. And let me take another moment to check the chat and the life of the stream, and we are good. Thanks again for leaving comments. Be stoic. Everybody else viewing, leave comments. Whether you're at the YouTube live premiere, we always view our videos live, by the way, or if you're on BitChute, or if you're viewing in syndication. Part of the reason I make these videos is because I watch them myself. And I would remind our viewers that I'm not only smAsho, but I am also a client. Anyway, here's the total electron content forecast, and we see standard anomalies here, as we typically do with very low levels of electron flux. You see significant electron density here at nighttime, especially around the equator, but also consistently over North America and Canada here. And keep in mind that is the entire air column all the way up to the thermosphere, and it will give you a great indication of GPS error levels. Here's just one slice. It's the ionosphere, and it's going to look a little bit anomalous here as well, as the ionosphere and the electron flux are inherently related. As the Earth's Van Allen belts have lots of electrons to give up and contribute to chemical reactions. Here's the latest image coming in at 10:30 Universal Time. Again, a little bit anomalous there, nothing to write home about. Got a volcanic uptick going on here a little bit. Let's run down volcanoes. This is an image of Klyuchevskoy, located on the Kamchatka Peninsula. And that one is from yesterday. So Klyuchevskoy has upticked a little bit. It's producing about a 10,000 foot ash plume there now. Sakurajima, back on the list, 9,000-foot ash plume there. Suwanosejima, flight level 060, it's a 6,000-foot ash plume there. Mount Ibu exploding, 7,000-foot ash plume there. Dakono exploding in similar fashion. Sangay exploding, flight level 200, a 20,000-foot ash plume above that caldera. Revenador exploding, flight level 150, a 15,000-foot ash plume. Sabancaya exploding, 21,000-foot ash plume there. Please do not attempt to pole vault the caldera, because you may not have Batacave care. And if you don't have Batacave care, well, Obama and I both agree that you should have Batacave care. Next, looking at earthquakes, which we usually cover first. Today, we're covering second. Past 24 saw a lull in earthquakes, although some Caribbean activity, it looks like, kicked up here. Let's see what's going on. Small deep quake in Alaska. Largest of the past 24 here is not even a 5 magnitude, it looks like. So a lull in earthquakes, and I would remind our viewers that we are still seeing a lull in large earthquakes. So 7, 8, and 9 magnitude earthquakes. There's been a drought over the past couple of years. Here's a deep quake in the northern Mariana Islands. It's at a 4.9 magnitude. And we're just going to scroll up the list. Leave us a comment here if we've left anything out that you want covered. And thanks to viewers who do leave comments. Lastly, a 4.4 deep quake in Afghanistan at over 160 kilometers depth. Next, looking at the jet streams here on nullschool.net. There are the jet streams of the Eastern world. And if you had to just see one worldwide basis on your weather, this might be the best choice. This gives you good insight into what it's likely to be like where you are, if you understand how to read the 250 hectopascals nullschool.net animation. Here are the jets of the Western world. And we are looking into the possibility of making lots more meteorology videos, as there seems to be a demand for that, and a demand for people who understand the physics sufficiently enough to comment on it. Next, we're at windy.com. We're going to advance this into tomorrow. We're looking at pressure cells here. So we've got isobars for barometric pressure. And you can see high pressure cells in red, low pressure cells in blue. Significant low pressure there out in the Aleutian Islands, perhaps raising the earthquake possibility for Alaska. Let's see if it behaves anomalously, rather. And it is. It's moving due north. So that, I would say that is an earthquake risk for the western Alaska region, certainly. Alaska, one of the only places we've seen a tsunami here in the past year or two. There's where we expect pressure cells to be at 12 noon tomorrow, according to the GFS forecast. I would note almost the entire lower 48 dominated by high pressure, likely to be clear days in those areas. Next, we'll look at lightningmaps.org. And there was quite a bit of lightning when I did show prep. Just let that populate for a minute there. Again, lightningmaps.org is where I go when I hear thunder. It even shows you sound wave propagation maps from lightning strikes. Perhaps check it out. Convince your friends that you're Thor, and your foes that you're Odin, Thor's Norse mythological godfather. Not his godfather, he's a mythological god who's his father. Please leave us a comment if you're a Viking. And here's the GOES 16 lightning mapper, and we still see significant lightning over the Caribbean. Next, we'll look at the U.S. Doppler Radar Map, as we like to add value-added services for our esteemed viewers. And thanks for tuning in. There's the current situation. Probably going to clear up by tomorrow. I'm not going to show the forecast. Here's what's going on in the cloud layer. So despite the fact that we're putting out this video while it's completely dark out, we show the cloud layer anyway. It's the NASA GOES shortwave radiation map in 3.9 nanometers. And I would note, check out the low clouds. Low clouds galore over the Gulf and the Atlantic Ocean once again. And by the way, low clouds are associated with cosmic ray flux, especially in the lower atmosphere, since it's denser between altitudes of, say, 15,000 feet and the ground, as those incoming protons are more likely to collide with things the denser the atmosphere gets. Next, looking at the U.S. water vapor map, and we're going to view actually the northern Colorado-Utah border here, as we see a massive gradient there associated with the southern Rockies. Just give that a minute to load. And we thank you for being an impatient viewer. Please leave a comment if you think you're more impatient than me. Personally, I have approximately zero patience, but I've learned to behave as if I do. So here's what's going on there. And we see a bunch of evaporation in this low pressure zone on the leeward side of those Rockies there in northern Utah, northern New Mexico there. And if you're on a plane going across this area, expect some massive turbulence when you hit that dry air or when you leave the dry air. Put it this way, if you're going this way or this way, it's going to be a bumpy ride in this area. And thanks for tuning in, everybody. It's about that time to vanish and move on to 3 more bonus features. We're going to show you the 94 angstroms SDO video of the past 2 days of solar activity. We're going to show you the colorized magnetogram. And we're going to show you the intensitygram to show you the current state of affairs for sunspot 2783. Here's the colorized magnetogram. And we haven't seen any trailing umbrae form yet. That is still an alpha class sunspot. And it looks like it's degraded a little bit since I did show prep. And indeed it has degraded a little bit since I did show prep. There is the current only umbra on the sun. Sunspot number is 11. And here's the 48-hour SDO video. Let's put up the water vapor map while that loads. And there's 48 hours of your local yellow dwarf. If you've got comments directly for the sun, perhaps I'll read them tomorrow in tomorrow's daily space weather video. Please leave a comment if you think the sun is conscious. We really should do a video about the Earth facing quiet effect, but not yet. Anyway, we're out. Thanks for tuning in. Remember, stare at the sun, don't drink it. If you do, don't drive. And since it'll never be now again, may that solar wind be at your back.